Hi, I'm Professor Steve Forsythe, and today I'm going to do maybe a short YouTube video, which is updating on Cronobacter sakazakii infections in the USA. The reason for this particular update is in response to a CDC paper that came out in March 2023, and I wanted to compare their results with what I had already reported and to add a little bit more information. Now, let me just say from the outset that the CDC use SNP analysis. I've been using a type of core genome MLST analysis. The two are complementary with respect to Cronobacter. And what I want to show in this video is how you can use the information of both techniques, complementary, etc. So if we go back, this is the Cronobacter genus. There's 7 species. The main clinically important ones are the Cronobacter sakazakii and the Cronobacter melanaticus. Now, using multilocus sequence typing, we can divide Sakazakii into just over 300 sequence types. What Susan Joseph and I showed a few years ago now is that when we look at cases of neonatal meningitis, and it's stated here in our paper in Emerging Infectious Disease, that the ST4, out of that like 300 group, that's the particular sequence type which appears to be a stable clone with a high propensity for neonatal meningitis. So we published that about 10 years ago, and so that's 1 out of the 300 odd sequence types. The other pathovars are your sequence type 12, which we find more associated with necrotizing enterocolitis. With regard to adults, the Cronobacter melanaticus sequence type, or clonal complex 7, is the more important one. Now, what we also did about 10 years ago, we went and sequence typed strains from powdered infant formula and milk powder production factories. We had a number of collaborators, and what we did, we looked at the number of strains in each sequence type from 3 previous publications. The one by Harry Moutjens was an international study from 1988. So we did the first multilocus sequence typing of that previous paper from 1988 because sequence typing wasn't available then. We also looked at Heather Craven's paper from 2010, the strains which had been collected in Australia, and we looked at the Jacobs ones from Germany of 2011. So it's a very broad, around the world international collection of strains from powdered infant formula and milk powder factories. And what we find is that 25% of those strains were the Cronobacter sakazakii sequence type clonal complex 4, which, as I said, is the genetic signature for neonatal meningitis. Currently, there's about 28 odd sequence types which are in the clonal complex 4. Now, sequence type 4 isn't the only version of Cronobacter sakazakii of importance. This is a paper from 2014, and you can see that clonal complex 4 is the most prolific one, and you can see the proportion at that time of clinical and infant formula isolates that we had in the database. But we also have clonal complex 1 and clonal complex 8, and that's the one which we'll be picking up on later in this video. Now, the reason for this specific YouTube is because I'm updating one that I uploaded just over a year ago. I uploaded it on the 26th of March 1922, and it was entitled Advanced Whole Genome MLST Analysis, and it had a subtitle of Neonatal Meningitic Cronobacter sakazakii Pathovar USA 2122. Now, in that paper, in that video over a year ago, if you go back, you have a look, you'll see that I did analysis of strains in the database, and of those which are Cronobacter sakazakii ST4, I said that there's a very interesting pairing. I said that there's a couple of pairs, one's clinical, one's infant formula, and another pair are here, one's a breast pump and the other one's clinical. So that was March 26th, 2022. I also, in that video last year, also showed you a nice pairing, which is of open formula and bottled water. And these are from the same state in America, the same month as well. And this was of Cronobacter sakazakii clonocomplex 8. And what I said, as always, is that if you see interesting results, then here are the contact people, here's the access for CDC and FDA. And as you know, that's what I do. Interestingly, 1 year later, we see this paper came out from the CDC in the Morbidity, Mortality Weekly Report, Cronobacter sakazakii infections in 2 infants linked to infant formula and breast pump equipment, USA 2122. Bit of an echo. And you can see all these authors which are there, and the date of that publication was the 3rd of March 2023, so it's virtually exactly 1 year after my own YouTube upload. And when we look at that MMWR report, we look at the table. It tells you the strains that the paper is based on. It has a biosample accession number for patient A and patient B. Curiously, whether they're typos, I've no idea, but for some reason they've duplicated the biosample accession numbers. So these are both doubled for some unknown reason. What I've added here are the strain numbers if you were to look at them in the PubMLST database. And here's the actual CDC strain number for those strains from patient A and those strains from patient B. If we now go to the figure from their paper, we have this SNP analysis. So they've done SNP analysis, I do core genome MLST. And here we've got isolates of patient A and patient B, and we've got a separate couple of isolates from an open water container and open formula, and we've got the SNP differences. Again, I'll add on the PubMLST strains so that you can go download the genomes of these strains yourself if you wish to. The point I wish to make is that that upper group are all that neonatal meningitic pathovar Cronobacter sakazakii ST4. Because the CDC don't do core genome MLST, they did SNP, so there's no mention of their paper that these strains here are the meningitic pathovar. And it's interesting, it's like confirmation when you look at their table, their paper, their figure, you can see cerebral spinal fluid isolate, cerebral spinal fluid isolate, that reinforcing that Cronobacter sakazakii ST4 is a neonatal meningitic pathovar compared to all like the 300 serotypes that we know exist, at least. If we now come down to the other part of their figure, here's again the equivalent strain numbers. If you're to go into the Cronobacter database and you want to access the data, the genomes there, and those genomes, we can group them together. They are the clonocomplex 8. Now, clonocomplex and sequence type can be a bit confusing, so I've done a very simple example here. When we look at the 7 loci, here is sequence type 8, and you can see that the loci that differs with sequence type 801 is the clint B1. So there's one loci difference. When we do eBurst, which is an automatic thing we can do in the PubMLST, we can find out which sequence types are similar to each other by number, and number 8 is in the middle. Sequence type 8 is in the middle, so that's what we name the clonal complex after. So sequence type 8 is the founder for clonal complex 8, and then we've got all these others, and they got one loci different. So here's 801, it's one loci different. If we were to look at the 7 loci for 130 or 781, we would find 2 loci different. So here we have one loci different, so it is in the clonal complex 8. Now, if we go back to their diagram, we got two groups of organisms, the CC4 and the CC8. And what's curious is that when you have a look, you find that the MMWR have actually omitted a couple of strains which are in the database. So one of the strains which they've omitted is in my database as 3444, and that's the CDC number. Here's the one for clonal complex 8, and you can look these up yourself and you can make a tree. That's what I've done here. So here's the ST4, the meningitic pathovar, which the CDC have omitted from their paper. And unfortunately, what we don't know, because they've omitted it, we don't know how many SNP differences there are between this clinical strain and the clinical strains over here. For those who are interested, I've used SB291 as the reference strain to root the splits tree analysis. And these are the other two clinical strains down here, or infant formula and clinical strain. So it's a shame that we don't know. It is a clinical isolate, and it looks like it's clustering with the others that the CDC reported, but they did not report that particular strain. Similarly, they did not report this clonal complex 8 strain. Here are the strains which they did report in their paper, and here's the third one. And again, you can go and download that genome for yourself, and you can do your own analysis. And for those who are interested, this is it's actually the type strain for Cronobacter sakazakii. It is an ST8 strain, so I've used that as a rooting organism for the splits tree analysis. So, simple conclusions. The MMWR paper, which was published the 3rd of March 2023, that's used SNP analysis to link a number of strains together, and those were previously linked by myself in my YouTube upload virtually a year before using core genome MLST. Before I go on to the next point, I have put the word linked in inverted commas because core genome MLST is looking at conserved genes. It's phylogeny. It's looking at clustering. It's looking at diversity, or more like clumping similar strains together because they have conserved genes. SNP linking is not the same as core genome linking. So I just wanted to put the word linked in inverted commas because it's not the same between SNP and core genome MLST. Second bullet point, MMWR strains were the neonatal meningitic pathovar, ST4. There were two cerebral spinal fluid isolates there, which were this meningitic pathovar, and that's a real red flag to me. If you detect the sequence type 4, then that's a real red flag, a real risk. And we also had this clonal complex 8 strains. The MMR, as I say, does have those CSF isolates, but curiously, there are two other strains which were not included in their paper, and therefore we don't know the SNP differences. It will be interesting to know. Again, I want to emphasize it's not that SNP and core genome MLST are in competition with one another. They are complementary techniques with regard to Cronobacter. And if you want to do your own analysis of core genome MLST, then the tools, everything I've shown you, getting that hold that data is freely accessible. You don't even register your interest. It's all there on the database page. So who am I? Spend time reading this. I'm so-called retired professor of microbiology. I've been external advisor for 5 WHO risk assessments on the safe microbial feeding of infants, and currently guest lecturer in various universities around the world. I've got over 150 peer-reviewed papers, something, I don't know, something about 90 or 100 on Cronobacter. I haven't counted recently at all. And I am the curator for the Cronobacter Pub MLST database and large number of collaborators. And if you want to get in contact with me, please, here's my email address. And if you want to look at my publications, then please just go to this website. The papers which I've referred to in this presentation are listed here, and hopefully you can just screen grab and you can like copy them down and look up those papers for yourself. Most of them are freely available here on the www.foodmicrobe.com website, or if you have any trouble, please just email me. So thanks for your attention and best wishes, and keep safe.